A cart of mass m naught is at rest on a rough horizontal surface. If bullets are bullets at the rate of lambda kg per second at an angle theta with a horizontal at a velocity u relative to the cart, the coefficient of the friction between the cart and the ground is mu. Find the velocity of the cart in terms of t. Okay, the cart moves while sliding. Let us say the bullets are ejected along this direction, so there will be a force applied F in this direction, and the same force, okay, will act, that is the reaction force, will act on this cart in the opposite direction in this. Okay, so this angle over here is equal to theta, so this will be equal to F cos theta, and in the downward direction it will be equal to F sin theta. In the downward direction it will be equal to F sin theta. Now over here let us proceed with this part. Besides this force, there is mg, that is of the cart, that is acting in the downward direction. Now if you consider the mass of the cart is given as m naught, that is initial mass of the cart, but it goes on losing mass in the form of the bullets. When the bullet is launched from this point, okay, there is a loss of mass, that is lambda will be equal to dm by dt. So dm will be equal to lambda dt, that is in time t, okay, I can say that the mass lost will be equal to m will be equal to lambda into t. Okay, m over here will be equal to lambda into t, that will be the mass lost. So the remaining mass of the cart will be equal to m naught minus lambda into t, because m naught minus m has been removed. Okay, or otherwise I can say that m mass has been removed, so it will be equal to m naught minus m. I will substitute the values later. Let this be the first equation over here. Okay, let this be the first equation. I will use this later. Okay. Now the normal force which acts in the upward direction, in the vertical upward direction, there is a normal force which is acting. So since the cart is sliding while it is moving, the total upward force will be equal to the total downward force. So the normal force over here will be equal to m naught minus m into g minus over here it will be equal to f sin theta. Okay, which can be written as the normal force which is acting, which can be written as, instead of m I will substitute lambda t into g minus f sin theta. Okay, minus f sin theta. Now this is the normal force. Okay, so the frictional force, if you can clearly see from this, is that the bullets, when it is fired on the right hand side, it will push the cart in the left hand side direction. So the frictional force will act in the opposite direction. Let the frictional force be equal to F. So the frictional force in this direction will be equal to F will be equal to mu times n, which will be equal to over here m naught minus lambda t into g minus f sin theta, the same value, the normal force, into the value of mu, this is the frictional force. Let this be the second equation. I will use this later. Okay, I will use this later. Okay, now over here, if the cart is going in the left hand side direction and the friction force is acting in the right hand side direction, the resultant force, I will write this as F resultant, will be equal to the force which is pushing it in the left hand side direction, which is equal to F cos theta. Okay, and the friction force which is pushing it in the right hand side direction, which is equal to the frictional force, which is equal to the force over here, that is the resultant force. First of all, it is acting on the mass m naught minus m. Okay, it is acting on the mass m naught minus m, it is not acting on just m naught. So it will be equal to m naught minus m into a will be equal to f cos theta. Let it be equal to as it is, f cos theta minus over here the frictional force over here is given as m naught minus lambda t into g minus f sin theta into mu. Okay, minus f sin theta into mu. This is the frictional force that is acting. Okay, this is the frictional force that is acting. Now instead of small m, I can write it as lambda into t. I have seen above that it is equal to lambda into t. So I will write this as lambda into t. Now what we have to do after this, we have to find out the velocity or the equation of the velocity in terms of, we have to find out the equation of the velocity in terms of time. You can clearly see I have got acceleration and I have got time over here. Okay, so we have to just write down the acceleration as dv by dt. Okay, dv by dt, m naught minus lambda t will be equal to, now this can be rearranged as f cos theta. Okay, minus of minus it will be equal to plus. Okay, minus of minus it will be over here equal to plus. Okay, so this will be equal to, this is, since it is in the opposite direction, this will be plus over here. Okay, So this will be plus over here because the total force is acting in the downward direction, not minus. Okay, the normal force is plus over here. Okay, so now over here this can be written as f cos theta minus f sin theta into mu will be equal to minus m naught minus lambda t into g. Okay, into g into mu. Okay, so now over here I have rearranged the term. Okay, now over here I can take f common. Okay, before I take f common, I will divide the whole equation by m naught minus lambda t, because I have to integrate the velocity. For that I have to divide the whole equation by m naught minus lambda t. So dv by dt will be equal to, I can take f common, it will be equal to cos theta minus mu sin theta divided by m naught minus lambda t, okay, minus mu into g. Okay, let this be whatever is this equation number, let this be third equation. Okay, I will use this later. We have to first find out the f over here. Okay, now f will be simply equal to dp divided by dt. Now f is the force produced. Okay, f is the thrust force that is produced due to the firing of the bullets. Okay, due to the firing of the bullets there is a thrust force produced, which is equal to f, which will be equal to dp divided by dt. Now over here the mass is changing but the velocity remains constant, so I can write this as u dm by dt, and dm by dt we have already seen it is equal to lambda, so it will be equal to u into lambda. Now u and lambda both are constant values. Okay, because it is going constant with respect to the cart. Okay, and lambda is also a constant value. Okay, so when I substitute over here, dv divided by dt will be equal to mu lambda into, over here it will be cos theta. Okay, it will be u lambda, not mu lambda, it will be equal to u lambda. Okay, cos theta minus mu sin theta divided by m naught minus lambda t. Okay, minus mu into g. Okay, we could have substituted that later too. Okay, this is equal to mu into g. Okay, over here. Okay. Now the last thing we have to find out the velocity, so I will integrate on both the sides with respect to time. So on the left hand side I will directly get the velocity. Okay, on the left hand side I will directly get the velocity. The limits are from 0 to v. Okay, initially the cart was at rest. On the right hand side, let me integrate this part first, because this is simple. It will be equal to minus mu g into t. Okay, it will be simply integrated as minus mu g into t. Let us find out this part, what are the constants, what are the variable. Mu, u and lambda is constant because the velocity of the bullet is constant, and lambda, that is the number of bullets those are fired per unit time, is also constant. Theta is constant, mu is constant, sin theta is constant, but this is the variable which can be integrated with respect to t. Okay, so the rest of the term I will take it as constant. It will be equal to u into lambda into cos theta minus mu sin theta. Okay, into integration of this part. Okay, integration of 1 by x is equal to log of m naught minus lambda t. Okay, divided by minus lambda. Okay, and the limits are from 0 to t. Okay, the limits are from 0 to t. When I substitute the limit on the left hand side, I will simply get it as v. Okay, it will be equal to u into lambda. Okay, or lambda and lambda will get cancelled out over here. Okay, lambda and lambda will get cancelled out over here. Okay, it will be equal to cos theta minus mu sin theta into log. When I substitute the value of the log over here, it will be equal to log of m naught minus lambda, okay, minus lambda t minus m naught. Okay, minus log of m naught. Okay, I have substituted upper limit and lower limit. When I substitute upper limit as t, I will get the first equation. When I substitute lower limit as 0, it will simply be equal to m naught. Okay, and there is a minus sign of this lambda also. Okay, I will write it somewhere over here. Okay, minus mu g into t. Now log a minus log b is equal to log a by b. Okay, so this part simply will be equal to u will be equal to cos theta minus mu sin theta. Okay, and there is a negative sign over here. Okay, there is a negative sign over here, so it will be equal to negative of, or negative a minus b. It will be equal to a, it will be equal to, simply if I insert the negative sign, this will be negative and this part will become positive over here. So it will be equal to log m naught divided by log m naught minus lambda naught. So simply it will be equal to log m naught divided by m naught minus lambda t. Okay, this will be the logarithm over here. minus, over here it will be equal to mu g into t. This will be the function of the velocity in terms of time.